everybody, it's Tyler here at the Week 0 event, checking in with team number 1073, the Force team. Absolutely incredible bot here with the Course of Showpiece, using suction effectively as well too on the field. So I can't wait to show more off about that. By the way, to speak more about this robot, I have Alex, Tom, and Megan. And by the way, 1073 last year, Excellence in Engineering Award at Championships, and it really goes into this robot here. You'll see as well too, that continuation of their legacy is just really shiny here. We'll also talk about their arm, some future plans for their vision, some of their autonomous that's gone into it, coming up here on Behind the Bumpers.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. FRC Premiere Night is back on Saturday, February 25th. Submit a unique video showcasing your team's charged up robot progress by Thursday, February 23rd at firstupdatesnow/premiere23. Premiere Night is a great way to engage with the community. Get more information and submit your video at firstupdatesnow.com/premiere23.
Starting your robot, I think we really do have to start with the suction here. It's such a showpiece of your robot. So talk to me more about, one, how did you determine that your team wanted to go with suction? Because we've seen teams that have tried it and then shifted away from it, but it's worked really well for the Force team. And then talk to me about overall design too.
Yeah, so we had a couple different iterations of the suction cups. We actually started out first, we have different end effectors in design as well, but currently we started out with stationary suction cups, but now we have these compliant ones. They're called bellow suction cups. And they have that compliancy you see, and you can see in some of our match videos, the cube is just hanging off the side of it, which actually, it's still on there until I spin it around, but it's still on there. We actually have it hooked up to a custom gearbox down at the bottom here. We took 5 off-the-shelf vacuum pumps, and we basically took off the motors that come with them and hooked them up to 3D printed pulleys, so the Falcon runs them. And it essentially powers all 5 of these separately, so that way if we don't get a full seal on one of them, we still have a full seal on the 4 other ones. We also have these bleed orifices right here. They are essentially little holes that allow the game piece to fall off once we stop powering the suction. That means that when we want to release the game piece, we do. We experimented with a couple different sizes of these to find the right size, because if they're too big, the piece falls off with very little effort, and if they're too small, the game piece doesn't fall for a couple seconds, which takes precious time away from our cycles.
I noticed you have some compliance here. There's a bearing that's on here as well too. So when you're looking at it, is that just to give it more give? Because when I watched a match and you came out to get a cube, it looked like you didn't exactly have to be right on. It kind of just almost like centered it because of this compliance that you have.
Yeah, so we have the compliance in the leg stand to start, and we also have this bearing down here. So when we pick up cones, we pick up from the back usually. So when we pick up a cone, we can bring it over the top of our robot and it'll rotate around. That way we can place it right up if we need to put it in the mid rungs where we can reach it.
Can we turn it on and see a cube? Come on, I'd love to see more about this.
It's very loud, sorry. Yeah. And it's on there.
I'm going to grab here a little bit. This got pretty good grip on it. I had to pull that pretty hard to get that off. So very interesting to see with that. And then one of the things you mentioned is that if you swing around too fast, sometimes it falls off. Have you been able to determine kind of where that limit is for how quick you can turn with it?
Yeah. So I have triggers on my controller, and essentially each of them adds the same amount. So it's about 1 trigger for me. It's more of a feeling thing and how secure I can see it's attached. But I spin around at a slower speed than when I drive.
I feel like the software team's going to limit you on their end.
They are already limiting me.
I see the gears turning for that already. Absolutely. Well, the suction is really cool. Were there any other designs for either suction or intake that your team went with prior to going with this?
Yeah, we have flat suction cups as well that we determined had too much give and we couldn't use them compliantly enough. We also have a claw in the works to hold it, so we have less of that issue when we're spinning around.
Sure.
Because the issue with suction cups is lateral motion, not the forward and back. They can hold it really tight. It's just when we spin around, it obviously falls off. So we're working on a gripper to hold it in place.
You also mentioned with cones that you do pick them up a certain way. Can we just kind of see like where do you pick up a cone from?
Absolutely. And then lift it over the top.
Let's keep moving on to your robot and talk about the arm itself. I know we showed it kind of move a little bit, but the packaging for this is quite interesting. So talking about when you were doing the design for it, how'd you come up with using this type of packaging for your arm?
Yeah, so well, honestly, we did a bunch of different arm designs. We had considered a telescoping arm for a while. We designed a couple. We have design review processes in our robot design system. So we had a lot of input from students and mentors alike on
Sure.
what would work and what wouldn't work. And we ended up with this, and then we worked the geometry a ton. Like that was a couple days just in CAD with just line drawings, making sure it could reach to where it needed to reach every way possible and store properly. Yeah, that it kind of just, we ended up being like, oh, this is the best way to store it out of the way. We can also store it face down with the game piece here. We haven't tried that yet because this just works for us right now. Yeah, we have 2 custom gearboxes running this. They're the same exact gearbox, so if one broke and we were like, we actually need this one more, we can switch them around. We have spare gears, all that, except they just run off of different ratios. So the one for this, we call it the elbow, is on a, it's a 40-to-1 right now. So the gearbox itself is a 20.6, I believe, so it's about 40.1 on that, and it's 80-to-1 on the shoulder gear. Yeah, and those run off of Falcons.
So let's keep moving on. As we talked a lot about the hardware side of things. Let's talk about some of the software side as it goes through. So looking at camera-wise and what you'll do, I do see a camera right here on your robot. So talking about what are you looking at doing like now, and then as you get into an early your early event, where do you want to be from that progress standpoint?
Yeah, so we have 2 cameras on our robot right now, one right here and one right here, so pointing at the front and at the back, and they're both connected to the Jetson Nano on the robot right here. So the Jetson Nano environment is based in Linux, and we code all of our cameras in Python. Fiducial marker detection, so specifically April Tag Family 16H5, was a huge priority for us.
Yeah.
So we started all of that code very early in the season, around January. And because the Jetson Nano is module, we can take it off of this robot. It's essentially a mini supercomputer. We can take it anywhere we want, set up a monitor, a keyboard, and a mouse and code. So once the Jetson Nano is connected to the robot, we get marker detection and live streams through our video servers. So eventually in week 1, we want to have a video server and marker detection detection so that when we go up to the markers on the field, the robot aligns to the closest marker central to the robot so that I can then place field elements autonomously.
Yeah, it makes sense. Obviously, a lot of work to do till that progress. You were telling me beforehand that program just got the robot to work on a couple days ago, so we'll give them a little bit of slack on that and hope their mechanical team gives them more time for that as well.
We had 6 days off because of snowstorms and just weather, so we're a little bit behind, but software has been able to sort of test all of these components individually on our practice robot Gladys, which has helped us bring this robot here today to the field.
Yeah, that's a great point. Having that practice robot can be really valuable as well too. Anything else from that end before we go into autonomous?
Yes, we do have a Pigeon IMU on this robot which helps with the charge station, so engaging on the charge station. We also have parking brakes. So once we get onto the charge station, no matter where it's tipped, the motors on the Swerve drivetrain will lock in place and set to 0 so that the robot physically cannot move. So no matter if a robot goes on top of the charge station or goes next to it or if anything is pushed, that'll stay stationary.
That's awesome. So cool to have that forethought of looking at the game and that you wanted to accomplish that, and it looks like it's going to be working out for you, so that's really cool with that too. For autonomous, I got to ask you on this, well, first off, what do you do for auto? How do you plan out your autonomous ahead of time? And then what are you looking at future plans-wise for your auto?
So for autonomous, we have these meetings to decide which autos we want to do at each event. And for this event, we have one auto that just leaves the community.
Sure.
One auto that goes and engages on the charging station, and then one auto that leaves the community and then comes back to engage on the charging station. And we also have like the no autonomous because we might.
Sure. Yeah. And then
we have been able to write auto routines so that we can push one of the game pieces into the lowest node, so simply just backing up the robot.
Makes sense. Is there anything, I know we talked about earlier, you might have something on screen we could show as well too. Can you talk to us about what's on screen right now?
So that's our shuffleboard layout. And for autonomous, we run for driving to points. We have a drive-through trajectory, and it's a command that we call in here, and we give it a list of points that we want it to go through, and we find those points by like driving around and looking at the odometry from our shuffleboard layout, and then putting it in, and the drive-through trajectory will go through those points and then end up facing any way you want, or like that. We actually spent a lot of time developing the trajectory. At first we used the class from WPI
Sure.
that uses the waypoints like we do now, except we found out that this class was for differential drive and not for swerve. So we sort of repurposed that class, like taking stuff out of it, keeping some stuff to fit for swerve. And we got that working, like she said, on the test robot. It's been really helpful to get our autos working.
Well, really looking forward to seeing what your team does as you approach your week 1 event as well too, and how you compete. But you've been looking really good here, especially at a week 0 event coming in. I think your team has really been one of the standouts here so far. So congratulations on that progress. But like I said, can't wait to see how you do at your district events as well too. So Force Team 1073, thank you so much for talking to us about this progress of your robot and such a cool design that's gone into it. Wish you best of luck, and can't wait to see how you do. Thanks a lot.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. FRC Premiere Night is back on Saturday, February 25th. Submit a unique video showcasing your team's charged up robot progress by Thursday, February 23rd at firstupdatesnow/premiere23. Premiere Night is a great way to engage with the community. Get more information and submit your video at firstupdatesnow.com/premiere23. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.